Welcome back to our video lessons. It's been a while. Okay, so tonight we're going to be looking at inequalities in triangles. We'll first look at inequality relationships that exist in a single triangle, and then we'll look at inequality relationships that exist when we're looking at two triangles. So in one triangle, we have some relationships between angles and sides. Okay, now before we look at this theorem, I would like you to recall, just visualize in your head, an isosceles triangle, right? Keep in mind that an isosceles triangle has congruent legs, and then the angles opposite those sides, right, those legs, are also congruent. So the base angles of an isosceles triangle are congruent, and the sides opposite those angles are also congruent to each other. Okay, so by similar reasoning, it should make sense, okay, that if those angles, if we want to call them the base angles, or if two angles of a triangle are not congruent, then the sides opposite them are not going to be congruent either, but there is a relationship that exists. If we're looking at a single triangle, we say that if two sides of a triangle are not congruent, the larger angle is opposite the longer side. Okay, so that's a relationship we've kind of talked about, we've touched on here and there, we just haven't been formal about it. So now we're going to formally say that in a triangle, when we have two non-congruent sides, the larger angle is opposite the longer side. And likewise, the converse is true. If two angles are not congruent, the longer side is opposite the larger angle. Let's look at an example. In triangle ABC, name the angles in order from smallest to largest. If we remember from our theorem that the smallest angle is going to be across from the shortest side, and we can see that the shortest side in this case is side AC, so our smallest angle is going to be angle B. The next shortest side is side BC, and the angle across from that is angle A. And then last but not least, angle C. So in order from smallest to largest, we have angle B, then angle A, and then angle C. Okay, now the converse of this in PQR, name the sides in order from smallest to largest. Okay, well, we got to do a small calculation here. If we have two angles of 60 and 72 degrees, okay, we know that the triangle sum theorem says that all three of them have to add to 180. That means that R is whatever the sum of angles P and Q are, and subtract that from 180. So 180 minus 132 is 48 degrees. Okay, so R is 48 degrees. Okay, and the shortest side is going to be across from the smallest angle. Okay, so the smallest angle is that 48 degrees, so that makes PQ the shortest side. Okay, the next smallest angle is angle P right here. Okay, so the next shortest side must be QR. And then finally the longest side is across from the largest angle, and that makes the longest side PR. Okay, so a slightly more challenging problem that has to do with the triangle inequality theorem. The lengths of two sides of a triangle are 17 centimeters and 12 centimeters. Oops. Find the range of possible lengths of the third side. Okay, so we'll call that third side X. And by the triangle inequality theorem, we have three relationships that must hold. 12 plus 17 must be greater than x. 12 plus x must be greater than 17. And 17 plus x must be greater than 12. So we're actually going to solve all of these three inequalities separately. So the first one, the solution of the first one is that x is less than 29. The solution to the second one is x is greater than 5. The solution to the third one is x is greater than negative 5. Okay, so we're going to take a look at these answers. Okay, so we've got 3 answers. We need to come up with one inequality that represents all of these answers, and all of these conditions need to be met. Okay, so the first actually issue I'd like to bring up here is this x is greater than -5. Now, we're talking about the side length of a triangle, so anything 0 or negative is going to be irrelevant here. Okay, so this x is greater than -5. It's not that the whole thing is irrelevant, but we're not going to have a negative side length. Okay, we also have this x is greater than 5 here, and if we need to meet both of these conditions, both the x is greater than 5 and x is greater than -5, okay, this x is greater than 5 is the one that's going to take care of meeting both of those conditions, because if we're greater than 5, we're automatically greater than -5. So even without the issue of a negative side length, this x is greater than 5 is going to take care of our constraints here. Okay, but in addition to that, x also has to be less than 29. So the range of possible values for x are anything from 5 to 29. So 5 is less than x, which is less than 29. And finally, we have inequality relationships that exist in 2 separate triangles as well. This is called the hinge theorem. Think of a hinge like on a door, right? A door opens and closes. If the angle changes, think of it that way. Okay? The hinge theorem says that if we have 2 triangles that have 2 pairs of congruent sides, so 2 sides of one triangle are congruent to 2 sides of another, and the included angles are not congruent. Okay, so take a look here in the diagram. We have AB and DE are congruent, and AC and DF are congruent. However, angle A and angle D are not congruent. The longer side is across from the larger angle. So again, it's very similar to that first relationship we saw in a single triangle. Okay, but now we're looking at 2 triangles. We're looking at 2 triangles that have some similarities about them. Okay, they have same side lengths. But now we can compare, we can make a comparison of those third side lengths if we know something about the relative size of the included angle. And the converse of the hinge theorem also holds. Okay, so if you have 2 sides of one triangle congruent to 2 sides of another, and the third sides are not congruent, the larger angle is across from the longer side. Okay, let's look at an example that deals with inequalities in 2 triangles now. We have 2 triangles. So this is really, these are related by the hinge theorem. Okay, the hinge theorem, if you think of that angle, that changing angle as a hinge. Okay, notice that in number 1, we have 2 triangles that have 2 congruent sides, right? So AB and DE are congruent, and so are BC and EF. Okay, but the third side is not congruent. So the question is, compare the measure of angle ABC and the measure of angle DEF. In other words, which one is larger? Okay, and the hinge theorem says that in 2 triangles that have 2 congruent sides with the third side not congruent, the larger angle is opposite the larger side, very similar to that single triangle theorem that we had. Okay, so when we make this comparison, we're going to say that measure of angle ABC is larger than the measure of angle DEF, and that's because the side opposite ABC is 12, while the side opposite DEF is 10, and 12 is obviously larger than 10. Okay, compare PS and QR. Okay, so in other words, which one is larger or which one is smaller? Okay, so again, by the converse of the hinge theorem, okay, if we're looking at side lengths, right, the shorter side length is opposite the shorter angle, assuming the other 2 sides of the triangle are congruent. So let's just make sure that they are. Okay, we have an 8 here and an 8 here, and then it doesn't matter what this is, by reflexive property, they share that side. Okay, so it's the same. It doesn't make a difference what the length of it is. It is the same in both triangles. So they do have two congruent side lengths. Okay, but these different angle measures here are going to lead us to conclude that side PS and side QR are different lengths. And in this case, the length of PS is less than the length of QR because PS is across from an 80-degree angle and QR is across from a 100-degree angle.